Welcome to the Makeup Lab for the rate law investigation. The corresponding page in the lab manual is going to look like this. There will be a question up at the top that says, what is the rate law for hydrochloric acid reacting with sodium thiosulfate? So this video is going to have a couple of goals. The first is to give you an introduction on chemical kinetics. Specifically, we're going to talk about collision theory a little bit and how that can be used to explain why reactions occur at different rates. Specifically today, we're going to be looking at how the concentration of reactants affects the rate and the particular reaction that you would have carried out in lab, and then how to derive an equation that explains how the concentration affects the rate, and this is known as a rate law. You'll be given some data to process on a spreadsheet, and then after that you will do a write-up. When reactions occur, they occur because particles successfully collide with each other. There are different factors that influence whether or not a collision is going to be successful. The first is how frequently the particles collide with each other. The more frequently they collide, the more likely there's going to be a successful collision. The second factor is the kinetic energy that the particles contain. This corresponds to temperature, so higher temperature means higher kinetic energy, and that's going to increase the likelihood that they'll have enough energy to overcome that threshold to produce products. Finally, the three-dimensional orientation at which the collision occurs also affects whether a collision is successful or not. Some orientations are less successful than others. For the lab today, we're going to be looking at influencing the frequency of reactions. So to simulate that, we have a box, and there's going to be two reactants that are going to be moving around. So I'm going to pump in the first one. So you can see them moving around, bumping into each other, colliding with each other. And then I'm going to add the other reactant here. Now, if I only put in one particle, that one particle is not going to collide with the other reactant as frequently than if I add a bunch of them. So by changing the amount of the particles, I change the frequency with which they collide with each other, and as a result, that usually causes the rate of the reaction to speed up. Here is the reaction that we would have carried out in lab. So what it is there's two reactants here. HCl is hydrochloric acid. Na2S2O3 is called sodium thiosulfate. And then when they collide with each other, in order for this to happen, two HCl particles have to collide with one sodium thiosulfate particle. And if that happens, we produce four different products. The one that we're using in this lab is going to be the sulfur. Sulfur is a yellow solid that precipitates out of the solution. So that's a visual indicator of the extent of the reaction. So what it looks like at the beginning when you mix the two solutions together, because the aqueous means that they're dissolved in water, it looks pretty clear. It doesn't have too much of a color. Over time, what happens is eventually the cloudiness builds up as the amount of sulfur forms, until ultimately what happens is the solution becomes completely opaque. And we can use that visual indicator and time it. We can see how long it takes for it to become completely opaque. So that's overall what's going on. Now, in order to see how each reactant affects the rate of the reaction, what we have to do is carry out some controlled reactions. So what I mean by that is we have to carry out a series of reactions where the amount of the hydrochloric acid changes, the amount of the sodium thiosulfate stays the same, and that way we can see specifically how changing the amount of hydrochloric acid affects the rate at which the reaction occurs, how much time it takes for the reaction to occur. So we'll do that, change it once, measure the time, change it again, measure the corresponding time again, and then one more time, measure the corresponding time. After that, in order to see how the other reactant affects the rate, we're going to have to flip the situation around. So we're going to have to change the sodium thiosulfate and keep the hydrochloric acid constant, and then see how that affects the speed at which the reaction occurs. An equation that shows how the concentration of the reactants affects the rate of the reaction is known as a rate law. So in here, the only two species that are appearing are the two reactants, HCl and Na2S2O3. This equation has two other distinct elements to it. We have this value, K, and then we also have these exponents. The K is known as the rate constant. This is a number that enables one side of the equation to equal the other. The exponents are what's known as reaction orders. So we just arbitrarily assign the letter X for HCl and the letter Y for the Na2S2O3. Now let's talk a little bit about these reaction orders. They can be small whole numbers, usually 0, 1, or 2, and sometimes you see 3. So if that equals 1, then that's going to govern how changing the concentration affects the rate. If that number happens to be a 1, let's say we double the concentration. If you double the concentration and that exponent equals 1, then that means it's going to have the same effect upon the rate. If you double the concentration, you're also going to double the rate. The term we would have for this type of relationship is directly proportional. If the reaction order happens to equal 2, and we do the same thing to the concentration, double it, what that's going to do is it's going to take that factor and raise it to the second power. So 2 to the second power equals 4, and what happens is the rate gets multiplied by 4. Another way of saying that is the rate quadruples. Sometimes you can have a reaction order of 0. What that means is if you double the concentration, you're raising that factor to the 0 power. Anything to the 0 power equals 1. So the rate is going to be multiplied by 1. Whenever you multiply a number by 1, you don't change the result. So when the reaction order is 0, it means that changing the concentration has no effect on the rate. So the way in which you're going to be processing the data is you're going to be given data for the reaction being run 6 times. In the first 3, the HCl is going to be changed, the sodium thiosulfate is going to stay exactly the same, and the total volume of the solution is going to stay exactly the same. This column here for water just means that we may have to add some water in here just to bring the total up to 35 milliliters. But that's what's happening in the first 3. Changing that, keeping that, and the total constant. Then in the next 3, we're going to flip it around. So we're going to change the amount of sodium thiosulfate, and this time we're going to keep the HCl the same, and again we're going to keep the total volume the same as well. The values that you'll see in the spreadsheet that you're going to work with are going to look like this. So you can see the numbers that are in blue are the numbers that are changing. The numbers that are in red are the numbers that are constant. And then you can see that as you go across the row, all the volumes add up to 35. The spreadsheet you're going to work with is going to look like this. It's going to say makeup lab, rate law for hydrochloric acid and sodium thiosulfate. This is going to be in read-only mode. So what that means is you have to make your own copy. So to do that, you're going to click File up at the top, and then make a copy, and you can save it to Google Drive, and you'll have your own copy to work with. This spreadsheet will walk you through more or less how to do these calculations. So what you'll do is, this is the raw data here. There'll be some values that will fill in automatically, so you want to leave those alone, the ones in red. And then it'll explain in a box below how to process the calculations. So this spreadsheet is going to proceed in this direction. So you're going to need to drag over, and then by the end you'll end up with the values for the reaction order and the values for the rate constant. If you have lab with me, Chris Ambrose, I'm going to show you where to access the files that you're going to need to do the write-up. So what you're going to need to do is go into Google Drive, and you're going to need to pull up your folder. So I made up a sample one here. So it's going to say Gen Chem Lab Spring 18, and then it'll have your day and time right here. In your folder, you're going to see the class edit, the class view, and then you're going to see the document on which you will write the report. The class edit folder doesn't have anything in it. The class view folder is going to have a couple of items in it. If you don't have the lab manual with you, there's a copy of it right here, so you can open that up and take a look at it. The next file is the actual data. So this is the data spreadsheet. Again, you're going to need to go to File and make a copy to process it yourself. So this is what it looks like. The next file is going to be some results. We're going to pretend that the whole class did it and got these results, and these results are compiled on a spreadsheet. So this file is going to look like this. So let's say 5 groups did it. These groups got this number for the exponent for HCl, and here's the average. And then for the other reactant, the groups got these numbers, and then the average is right there. And then finally, here's the rate constants, and they're all average right there. So these are going to be the pretend overall class results, because you need to discuss that in the write-up. Finally, this is, as before, this is going to have the rubric for the write-up. It's going to be the same rubric as the previous write-up. The final thing to mention is where you're going to do the write-up. So what you'll see is there should be a new document in your folder that's going to say your last name, your first name, investigation 2, rate law for hydrochloric acid and sodium thiosulfate. So when you open it, it's going to look like this. And what you'll see is it looks very similar to the first write-up that you did. There's going to be a detailed outline that is by and large the same. The only differences will be highlighted in blue. So anything that's pertinent to this particular investigation will be included here. Again, these are going to be graded according to the same criteria though, so keep that in mind. So the way this is going to work is the write-up is going to be due the next time we have lab, and that is going to need to be a rough draft. Just like last time, we will do peer review, and then you'll be given 1 more week to finalize your edits and have a final draft. So again, I would keep this outline on here when you're typing and when you do your rough draft, but delete it before you do the final draft. And this rough draft is going to be due the next time that we have lab, so that will be after break. If you have any questions, please feel free to contact me. Good luck and thank you.